Hi, hope you're doing well out there. I'm Bob Hughes with JD Squared. Appreciate you taking your time out to view the video. Anyway, what I'm going to be talking about in this one is the flat plate and true shape nesting features in Camelot, basically how to use it. Now, technically, you can see on the screen right up here in the top left, it says we're still in beta, and we kind of are. It works, I would say 90 something percent of the time. It works absolutely flawless. For all your simple parts, it does. But however, on some things, we have had issues where we brought in some very complicated DXFs that are not healed. And healed means that you got lines that don't touch. You need to connect them and stuff like that. We haven't done all that yet. So if it's a proper DXF, if it's properly done, Camelot is handling it real, real well. So without further ado, let's go ahead and get after this. Okay, I shrunk my ugly face down to the top corner. You don't need to see that anymore. You're not going to see me on GQ magazine anyway soon, so let's minimize that. Put my glasses on so I can see what's happening, and let's do this. First thing I need to do is click Create Sheet Metal Job Beta. All this terminology will change once we finalize it. Right now, these are just terms that we used in a hurry. So we'll click that, and that's going to bring us to our flat plate processing module in Camelot. Now, Camelot will not only process rotary pipe, structural, stuff like that, it will also work with flat plates. A lot of people don't know that. In fact, we're getting ready to start giving away versions of our Camelot to everybody who's ever bought a flat plate plasma machine off us. Will be getting this software for free once we finalize a couple little things we're working on. All right, so let's talk about the first thing we need to do is tell it what is the plate that we're cutting. Now, we're talking about the size of the plate, not the thickness. If we come up here to the top right, add or modify raw plates, you're going to see two tabs. Raw plate rectangular, once again, it could be square, so we'll have to change that name, or raw plate from DXF. And that's the cool thing that I'm going to show you here after we get done with this right here. So let's look at raw plate rectangular. Now, I can type in the values of the size of the plate that I have. Let's just say I have a drop and I've cut it. Or I could go up here from a drop down. So for instance, I have a 4x8 foot sheet defined, a 5x10. There's a 36 by 36. If you want to add to that list, let's say you buy a lot of material, and let's just say it's 24 by 36, just any numbers. I could go ahead and add predefined shape. Now when I go to my drop down, I now have 24 by 36. We'll go ahead and use that. Let's hit add a new rectangular plate. There you go. That's your 24 by 36 plate. The very next thing we need to do is go ahead and tell Camelot the origin point on the plate. And that origin point is referring to the 0, 0 part on your X and your Y axis right here. Right now it's set at the lower left corner. If you were to look at this plate here, it's going to be sitting in your machine kind of like, you know, that right there. So generally, almost all the time, you're going to be at the lower left of the plate. Now, that's not necessarily the real plate. That's the origin of the G code that's going to be kicked out to cut all your parts. But most people just kind of like whenever you got to put the part somewhere. So imagine this plate as being just a flat surface that we're putting these parts on, and then we're going to take dab shapes and cut it out of an actual sheet of metal. So if we want to, we can move that origin by basically select origin, and that'll give you 9 places to, whoops, let me do it again, 9 places that you could pick for that origin right there. Let me rotate this a little bit so I can see it better. Select origin. So like for instance, I could say I want the origin to go there. I have no idea why I was having a little bit of trouble doing it earlier. Or I could actually say, oh, I know what it is. I didn't select the point, my bad. I could pick it to go in the middle of the plate. Now it'll tell you the dimensions right here. One day down the road, we may actually let you type in these dimensions. There's really no reason we could think of, but right now they're just showing you where they're at. We want the lower left hand corner because as I mentioned, that's the most common one. And we are pretty much done right here, and we can go ahead and close out from our plate and origin selection panel. Let's go ahead and add some parts to it. I'm going to come over here into the parts panel, and I am going to select parts, plus, click the plus sign. And in this folder, I'm just going to pick a few different parts. I'll pick a C, a 1-inch disc. I want to pick a JD Squared logo wrap, not Joe. Let's pick a small rectangular and a pointed L. Those 5 parts will more than suffice to show you what's going on. Now, what it's doing is it's processing these parts and it's going to show them up over here. If you notice, Camelot creates a actual little icon to show you what the part looks like. If I click on any of these, you can actually see the part you're going to be cutting. So we've done that. Now, the next thing we're going to want to do is go ahead and assign operations. In other words, do we want to scribe, cut, whatever we want to do to these parts? Most of the time, you're going to load up a part like this and you're going to just cut the inside, the holes out and everything like that. So since this is a quick little video, let's just assume that's what we're going to do. Other videos, I'll be showing you how to move things to different layers and parts, stuff like that. Now, let's go ahead and go down here to Add Operations, click the plus button. And I got a first thing I want to do is select the consumables that are in the plasma on the plasma cutter itself. I think we have 40 or 65 amp shielded is loaded. Now we need to know that because it's going to tell us the kerf width right here, how far to offset the torch so that we get the actual shape. You can override all this by going to manual contour offset. So let's say I wanted a particular hole larger. I could move that hole to another layer and then change this offset value. So if, for instance, it's 32.5 thousandths of an inch right now offset. If I change it to 0, that hole is going to be a 1/16 of an inch oversize, or 0.065 anyway, because it's 2 times the offset value. So other videos will explain that a little bit more. Most of the time, you're going to leave it in the use half of the kerf width value because we want to be in the middle of the kerf. Now, kerf is that groove that is being cut out of the plate by the torch. Now, I'm just going to go over here and I'm going to hit the quick button, Make Operations for all layers. There's 2 layers over here, an outside layer. If I move this over, that's all of your outside cuts, and then there's an inside layer, which is this one right here. Let's go ahead and hit Make Operations. And there they are. So if I click on the operations, you can see what's happening right here. They're all highlighted. And if I zoom in, you notice the inside operations have offset the path to the inside, and the outside operations have moved it to the outside. So operation selection, we're done with that. I forgot to mention, there's actually 2 ways to add parts. You could click the button over here, or you could add a part from a DXF over here. Let's go ahead and close that tool right there. Now, what we're going to want to do is place the parts onto the plate. Now, there are 2 ways to do this. We could do it fully automatic, which I will show you here in a minute, or we could do it manually. So if I grab a part right here, go back to my nest plate. Notice the 2 tabs. You got plate view, which is actually your part, so we'll have to rename that to part view. Here's nest view. Drag the part onto the plate. I could drag as many as I want. I could drag the pointed L, do whatever I want, and get them on there. Now, once I've got them on there, now I can actually edit it over here. So I could copy it. I could rotate it. So that particular part, I want to rotate it a few times, and then I want to drag it to there. This one here, maybe, I'm sorry. Let me get the different part. Let me get this one here. I'll drag it out of the way. Let's do this right here. Let's go to the top. Now we can see it really easy, right? This is your view selector box up here, and that's where you could pick to look at it. So right here, for instance, I click this one. Let's go ahead and move it over to there. And let's move this one in a little bit right here. This one here, I need to rotate, and then I'm going to tuck that into right there. That's one way of doing it. Now I could close out the parts right here, go back to this view, and there's my parts. At this point, I could hit the Run Post Processor, generate the G-code, head on out to the machine I'm cutting. However, there's another way of doing it. So let's say on the C, first I'm going to hit Control Z, which will basically back us up. I'm hitting it multiple times. I'm just getting rid of the parts, right? I could go along and say, okay, under the desired number of C's, I want 4 of these. I'm just making up numbers, by the way. On the disc, the 1-inch disc, I'll do 15. The JD2 wrap, I'll do 2. Pointed L, I'll do 3. And then the small rectangle, I'll do 2. Well, I'm just typing in numbers. That's all I'm doing. All right, let's go back to the nest view. Now, I want to place all of those parts onto this plate in the smallest available space that I can do it. I'm going to click Auto Nest Plates right here. Now, over here, you have your different choices of things you can do. the difference between a very expensive flat CAD program when it comes to true shape nesting anyway, and a cheaper one that may have it in. I'm talking the difference between maybe a $3,000 or $4,000 program and a $15,000 to $20,000 program. A lot of times what I've learned talking to the salespeople is the lower the product, in other words, what they call their hobby versions or whatever, I guess, it's how many times the true shape algorithm will try to compress the parts into the smallest shape. At JD Squared, we thought, why make that an arbitrary number? Why not just let the user decide? So what we've done is as soon as I click this nesting button, it's going to start doing its thing. And it's going to keep doing it until I tell it to stop. And for instance, I could say, go ahead, find me the smallest plate, the smallest amount of area. I'm going to lunch, you know. Typically, you're not going to do that because after about 9 to 12 iterations, it's going to find relatively the smallest space. Now, up here in all of these options, space between parts, for instance, I've got it set at 0.25 inches. Use the holes in parts. In other words, if I have a hole in the middle of a part and another part will fit into that hole, do you want me to put it in it or do you want me to not fill those holes? You've got other things also. Rotations is a big deal. Typically, it's set at 4, and what that means is it's going to rotate every part up to 90 degrees to find out the best possible fit. Now, depending on the shape of the part, you may want to increase that to 8 or 12 a rotation. So if you increase that 8, it's going to rotate the part 45, 90, etc., and try to find the best fit. That will dramatically increase the time it takes to nest. So in all of my years when we've used true shape nesting at the laser, we've always just done it 4 times. Anyway, I'm going to go ahead and hit the Make Nesting button. And there you go. That's our, now notice it's changing. Let me zoom in a little bit. You can see better. See it changing. It keeps getting smaller. Right over here, it's telling you the area efficiency. So it was 83, 84%. But I'm looking at it and I'm not really seeing it getting any better right now. Because remember, I put in values. I need the parts 1/4 of an inch apart, etc. So bottom line is, I don't know how many iterations we made. It looks like overruled results is at 13, now 14, which means it's changed its mind 14 times. That's an iteration. Let's just go ahead and click the Apply Best Method, and there you go. That is, whoops, let's go here. That is true shape nesting, folks. That's pretty darn cool, right? So that's how you would do it. Now, the very next step is we'll close out of this tool. We'll go over here to Run Post Processor so that we could actually generate G-code to take to the machine. Give it a name. So let's call this Fun Times, baby. And we'll say Save. And there's your G-code. We put that, take it out of the folder, put it on a USB, go out to the machine, we start cutting. Now, there is something else that we could do also. We could animate the entire process. Let's just say, for instance, you want to verify or you want to see what this thing is going to do. Let me rotate around. I always have trouble rotating parts. I don't know what that means. All right, I guess all those times people told me to sit on it and rotate, I didn't understand what they're talking about. Maybe I have problems rotating stuff. But anyway, here's our part. Now, if I hit animate, it'll start doing its thing. The torch will start moving. Or I could just drag the scroll bar down and I could kind of verify, yeah, that's what I want to do. And then I could, once again, yeah, that's perfect. I'm going to head on out to the machine and cut it. All right, so we've done all of that. Let's go ahead and go back to our plate view or whatever. Let's see, we go back to here. That's the quick and easy way to do it. That's what you're going to do 99.9% of the time. That's what we do in the lasers out there. We load up parts, tell it how many we want, cut it. Now, can I work with this plate more? After I true shape nested it, yes, I can drag parts onto the plate and then rerun the post processor and process that. Now, here's something I want you to take note of. I'm going to drag another one of these parts here onto our plate, and I'm going to put it there. Now I need to zoom in, and I want to move this one over just a little bit. I'm just clicking on it with my left mouse button. Okay, we're good. Close the tool. Once again, I would have to rerun the post processor because I changed the number of parts that we put on the plate. So let's go ahead and rerun it just for giggles. What the heck? We'll pick fun times again. And there we go. There's our G code. We're done, right? We head to the plate. We're finished. Here's the cool part. This is where Camelot sets itself apart. And once again, I did mention we're in beta, but this works really, really well right here. Anyway, let's go ahead and close this job out entirely. We're going to start a whole new job. Oh, I'm sorry. Woo, thank God it asked me, do I want to save it? I don't want to save it. What I want to do before I leave is I want to go to export rest material to a DXF. And the rest of the material is just that, the rest of the material. So I'm going to click export it. I'm going to give it a name. Let's just call it Fun Times Rest, just so that I know what it is. Now, in the real world, what I would do is probably give this plate a number. You know what? In fact, let's do that. Let's go back and call it number Lucky 13. It's our 13th plate right here. We're going to call it that, and we're going to say save. Okay. Export of rest material success. Now we're going to get out of Dodge. We're going to go ahead and close out all of our windows. We're finished with what we're doing, right? Let me close this one too. Okay, we're starting over. Now, watch this. Let's go ahead and create a new sheet metal job. Now, the idea is that we named that plate 13. So I'm going to take my yellow metal marker, go out to the plate, and I'm going to write on it 13. So we know that it's plate number 13. Now, instead of predefining or telling it how big the plate is, I'm going to go raw plate from DXF, click the button. I'm going to select number 13 here. There's our plate with all of the cutouts already cut out in it. Let's go ahead and add a part here real quick. I'm going to go ahead and close this tool here. Let's add a part. And I'm just going to do something. I don't know. Let's find out what the heck Joe is. I don't even know what Joe is. Let's find out. Obviously, it was a customer who came in. So we'll give it a second. We're not cutting Joe. I guess I was showing him how to do a whole plate. And what I was showing him how to array parts. So you can pick a part and you can array it. I want 25 of these parts, and you can do it. I'll show you that in another video. In the meantime, let's delete Joe. Let's go add another part, something that we could work with. Hey, how about the JD2 logo? I hear they're a pretty cool company. We'll try that. Let's go back to our nest view. Watch this. Now I'm going to start dragging my parts onto my plate. I already know what part of the plate has been cut out, so I can do this. And I will give you an exact explanation of why this is super important. Let's go ahead and add another part. Let's, I don't know, we're going to add something silly. Let's add the little 1-inch circles, okay? Go back here. I am going to drag some circles onto it, but here's what I'm looking for. I want to see, can I drag I could put a circle right between those two parts right there. I can also place one right here. Let's see if we can squeeze one in there. Yeah, looking good, right? So what I've been able to do just now was use parts of a plate that normally would go in the scraps dumpster. The price of steel these days, I think the days of low-cost steel is over. It looks like we've stabilized at about 200% higher than it was a year and a half ago. I don't know if you know, it went up to 400-500% higher, but it's come back down to 200%. With all the problems in China, and I'll tell you an interesting story. You're watching the video, what the hell? China is the #1 exporter of steel in the world. They are also the #1 importer of steel. That sounds weird, right? What it is China doesn't know how to make good steel. So they export a crap load of your lower quality steel, such as your 836 plates, stuff like that. They're good at making that. They're not good at doing alloys at all. So they import all that. Therefore, they're the largest importer and exporter. Just thought I'd throw out a little trivia there for you. Kind of interesting. So anyway, the bottom line is the days of low-cost steel are over. Get used to it. We're about 200% greater. So you want to use as much plate as you possibly can. When we came up with the idea of saving the rest of the plate, there is another company that does this, by the way. I discovered them after we had implemented. I think they're called, Oh, artcutting.com. They got some pretty doggone cool software, by the way. They make very nice machines, very expensive machines. And I believe their software does this also. So we can't say we're the only people out there in the world, but we do it. All right, so at this point, I can come along and close this part. Once again, go over here, run the post processor. Oh, I'm sorry, got an added operation. The program will remind you if you make a mistake. I'm going to go back to my 65 amp shielded consumables, make operations for all layers. Now, watch this. If I go to, we got to run the post processor first, and we'll call it fun times again. We don't really care. Now, if I animate, you see what it's doing. It's cutting just the parts that we told it to cut, right? That's pretty darn cool. Now, if I go back to my plate, what I would do at this point, this is plate number 13. Remember, I'm going to go ahead, and before I head to the machine and cut this, I am going to export this part again, and I'm going to recall it. I'm just going to bring it up 13 again. So I say, okay, and I'll show you what's going to happen. We head out to the machine. Let's go ahead and bounce out of this. Oh, but no, before I do that, let me tell you why we're doing this. The typical way to cut plate, goes on our $750,000 laser out there. It goes on if you build your own machine for $2,000, same thing. Typically what will happen is you're going to move the torch head or a laser pointer. All of our machines are equipped with a laser pointer, but let's just say you had the super low buck machine and you only had a torch. You're going to move the torch to where you want to tell the cutting machine this is 0, 0. This is your start point, right? And then you're going to start cutting, but you want to verify that you're in that area, that you're not going to run off the plate. It's a pain in the butt, right? Now, suppose that we wanted to put some parts in this that had some weird angles, but we had enough room to squeeze it into other parts. This is where this technique is beautiful, because what Camelot's supposed to do, it's going to generate code, whereas the corner of the plate is 0, 0. So when you load up plate 13, you're going to run the laser up one edge just to make sure that it's true, that the plate is square to the machine. You're going to move the laser to in this case, the lower left corner, and we're going to click origin. This is our origin point right there. At that point in the future, well, now you can start cutting. It'll come along and cut them out. Now, a feature that we're going to be adding in the future, we've got a huge list of stuff. We got really great software, really great machines. That doesn't mean you stop. You never sit down. You keep pushing all the time. And that's the way we feel here. So we have a really cool list of neat features that we're going to be bringing out. And at the machine, we want to be able to verify this cut before we actually cut it, because we're cutting between parts, right? So in the future, we're going to be adding a verification button. It'll turn the laser on, move the laser pointer, and basically trace where it's going to cut your plate out. That way you get a visual representation or verification that, yeah, it's going to cut it. It's going to cut it right. We're not going to run off. Remember, maximum usability of your material. That is the idea. So that is the premise of what we're trying to accomplish right here. I'm going to go ahead. I exported it to rest, and I will just show you that real quick. We're not going to save the job. We don't need to. Let's go ahead and create another job real quick. I got a really fast computer here, and I sit in front of it yelling, hurry up. It's almost like, if I put instant coffee in a microwave, I'm impatient. Come on, let's go. You would think I'd be in a time machine, instant coffee in a microwave. I'd have to go back in time. I think I got that from that comedian. Oh, God, I can't remember his name. The one was very straight, monotone voice, Steve something or whatever. Funny guy. Anyway, let's go ahead and pick a raw plate. Let's bring back in 13. There you go. There's the cuts that we made. At this point, I could repeat the process. Anyway, I just wanted to give you a quick overview on the flat plate processing. Remember, our rotary cutters handle flat plate all the time. The only restriction, of course, is it's got to fit into the rotary cutter, because you can look at a rotary cutter as just one narrow, really long flatbed cutting machine. So that's why we went ahead and developed the flat plate. The other reason we did it is because we can work off of parts like, let's say you have channel, and you got a 12-inch channel, you put it into our rotary cutter or on top of a flatbed machine, and you just want to cut your logos into this flat plate. That's where flat plate processing comes in handy. Anyway, I hope this video has helped everybody out. We think we're probably 3 to 6 months away from saying go with it, go with just use it. We got hundreds of people currently using it right now. Everybody seems to like it. There are a couple of hiccups. I'm not going to tell you what they are. They're hard to find. Only one person has basically got back with us with one of them, and it had to do with that DXF not healing itself because they were artists and they get a lot of parts off Etsy, and some of those DXFs are written by are done by amateurs, or the program they're using put out, like for instance, lines on top of lines. You can't cut a line on top of a line that's already been cut. There's no metal there, things like that. So we have to correct that healing and some other stuff. But anyway, once again, I really appreciate you taking your time out. I hope you have a great day, night, whatever where the heck you're at. And I hope you tune in again soon. Thanks a bunch. Goodbye.